Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris and I am going to talk about background and the physics concept. Seabed sediment are really important for marine research and coastal management because they tell us a lot about the ocean floor. Things like what material are down there and even how healthy the marine environment is. The way of studying this sediment usually involves taking physical sample, which is expensive, slow, and can disturb the environment. Nowadays, scientists use a newer and cleaner method that involves acoustic wave, basically sound wave that travel through water into the seabed. This wave bounce back differently depending on the density, porosity, and layer composition of the sediment. So, this technique lets scientists map and classify the seabed without digging it up. And it's also faster, cheaper, and doesn't harm the environment, neither the ecosystem. And now for the physics concept. The physics behind this involves a few key concepts. First, there is Snell's law, which explains how sound waves bend or refract when moving between material with different densities, like from water into the seabed. Then, we have wave reflection. When a sound wave hits a new layer, some of it bounces back. Scientists measure this reflected wave to understand what kind of material the wave hit. Lastly, there's something called impedance contrast. This means that the strength of the reflected sound depends on how big the differences is between the two material density and the wave speed. In short, by studying how sound drift reflected and reflect, we can figure out the structure of and type of sediment beneath the ocean floor.
Assalamualaikum, my name is Lukman Saidin and I will talk about two parts, which is application and findings. For acoustic wave, the technique used to study the seabed is called sub-bottom profiling. It's a type of acoustic or sonar method that sends sound pulse downward through the water and into the seabed. The sound waves travel to the sediment layers, and when they hit the boundaries like different materials such as mud, sand, or rock, they bounce back as an echoes. The main component used in this system are the transducer, the hydrophone, and the data recorder. The transducer acts as a both transmitter and receiver. It converts electrical energy into sound wave and also receives the returning echoes. The hydrophone is a special underwater microphone that detects this reflected sound wave and converts them into electrical signal. The data collected is then processed by a sub-bottom profiler, which creates a vertical image or profile of the seabed layers. This allows scientists to visualize the thickness and the structure of the sediment beneath the seafloor. For the findings, the acoustic data shows how sound waves behave differently depending on the type of sediment. In the graph here, we can see that the density of the sediment increase, the reflection strength also becomes stronger. This usually happens in compact sand or rock layers. On the other hand, the soft sediment like mud have higher porosity, which means the sound wave travels slower and reflect weaker. So, by looking at these reflection patterns and sound speeds, scientists can identify which area contains soft sediment and which area are denser or rockier. This helps in many applications, for example, locating stable areas for marine construction or detecting hydrocarbon reservoir. Even though the graph I'm showing here is this example data, they represent the kind of acoustic reflection result that real sub-bottom profiling survey would produce.
Assalamualaikum and hi. My name is Muhammad Ibrahim, matrix number E20403562. Today, I'm going to talk about acoustic wave in sediment characterization. I'm going to talk about implication and the reflection. First of all, we're going to talk about the implication. The first point that I'm going to talk about is it is used for non-invasive sediment analysis that usually found inside the water. Second, it is also used to find hydrocarbon inside the wave, and also to find some geohazard that may be geohazard lah. And the last and the most notable part of the acoustic wave in sediment characterization is it is used to, let me check it first. It is to support marine construction and environmental monitoring in the sea. Next point, I'm going to talk about the reflection, or also known as the disadvantages of the acoustic wave in sediment characterization. The first one is resolution decrease with depth. Second, requires strong contrast for clear reflection. And the last one is noise and multiple reflection can distort result. That's all for me. Thank you. Oh.